ellipses. So first thing with ellipses, everything we learned before is still going to work. We still have this directrix idea and focal points. So we're going to locate a point here, F, focal point, and we're going to have a directrix. Unfortunately, it's going to be a little messier than what we had before. We're going to take a point that's going to be P. We're going to go to the focal point, and then we're going to go straight across to the directrix. So we're going to take a point, we'll call it P, X comma Y, and this is a point N on here. Now this is the part that's kind of interesting, is what do you think the ratio of Pn over Pf is going to be? Did I do that backwards though? I want to do it the other way. Pf over Pn. What's that going to be? It was before, it is today. Not 1. It was for the parabola, but it's still our eccentricity E. Now, what if I went, instead of to this directrix, let's say I went to another directrix, or let's see, I went from here to here. Yeah, this is fine. Let's say I went to, that is point, yeah. So do you agree with this? This is all fine? Now what we're going to do is we're going to go to an A and a B. We're going to move this P down here to point A, and then we'll also look at this point B. So everything gets kind of moved a little bit. This X gets moved down to here, and then this point, this distance here, and this distance here gets moved down. Now what should happen though with the ratio of this P, or let's see, instead of P, AF over AN, what should that be equal to? E. And what about BF over BN? What should that be equal to? Still E. So this is the part that's kind of interesting. Now we're going to pick on some coordinates here. This center is 0, 0. Okay, and we're going to call this focal point. We call this A comma 0. We're going to call this H comma 0. And then this is going to be K, X equal to K. So this point here is going to be K comma 0. What will this point B become? Can you tell me what that is? Negative A comma 0. Give you a chance to write that down. So those points are going to be key to making this all work. So here's 0, 0, H comma 0. I don't like that H because it makes me think of the center of a circle, H comma K. The center of the ellipse here is 0, 0, but we'll bear with it. K is a very constant for the directrix. A is a constant for what we call the major axis. So now we should be able to label these. A to F. So I'm going to put this in here. To get AF, isn't this just going to be A what? A minus H. And what's AN going to be? From A to N, it's going to be from here to here. K minus A. Now we're going to do BF. To get to F, to B, it's going to be H, and then you're going to go a distance of how far? Well, I'm going to go H, and I'm going to go A plus H. Because this, even though it's negative A, it's still a distance of A and a distance of H. So this is A, and this is H. So then BN, B to N is going to be how far? A plus K. You got it. Now these E's are the same, so now what we're going to be able to do is we're going to be able to solve for these. And I think what they did is they just cross-multiplied and they said K minus A times E equals A minus H, and A plus K times E is equal to A plus H. Erase this a little bit. Multiplying those out, I get KE minus AE equals A minus H, and A KE plus AE equals A plus H. Here's my favorite part of this whole thing. I'm going to group this, clone it. We're going to do this twice. The first time, we're just going to add these up. So what's KE plus KE? KE plus KE? 2KE. What is negative AE plus AE? 0. A plus A is 2A. H minus H is 0. Divide by 2. KE equals A. So K has a coordinate of A over E. That is the equation of the directrix. Well, I shouldn't write that there. I should write it right down here. X equal to A over E is the directrix for a parabola. And there's one on the other side, so it'll be plus and minus. There'll be two of them. What do you think I'm going to do with this side? Any ideas? Yeah, I'm going to subtract everything, multiply both sides by -1. Now when I add these, this will be 0. I'll get negative 2AE. A minus A is 0. Negative 2H divided by -2. And I get H is equal to AE. The focal points will be 0, comma, plus or minus AE. Now, A comes from directly from the equation, and we're going to come back to that. But are you okay with those two? Okay. Nice job. So from the equation, this A value, this distance here, all the way across, is called the major axis. This is called the minor axis. The distance here is called B. The distance here, as we've said before, is called A. A and B. Now, where do those A and B's come from? We've got one more step to do that. I hope you're ready for this. Now go to a blank spot again, and we're going to draw half of a fourth of the ellipse. This is the focal point, AE comma 0, and this is the directrix, which is x equal to negative or positive A over E. We just proved those. Now I'm going to be fancy here. I'm going to go to a point on the ellipse PXY, and I'm going to go straight across here to N, which is going to be A over E, comma Y. Here are 3 points. And remember that PF, this is F, PF over PN, what's that equal to? E. So PF is equal to E times PN. Now, would you use your mathematical skills, find the distance formula P to F, use the distance formula to find P to N, don't forget to multiply by E, and simplify. So PF is going to be X minus AE squared plus Y minus 0 squared. E times Pn is going to be X minus A over E squared plus Y minus Y, which is 0. So go ahead and expand that. You get X squared minus 2AE plus A squared E squared plus Y squared equals E times X squared minus 2AX over E plus A squared over E squared. Simplifying that, EX squared minus 2AX plus A squared over E is equal to X squared minus 2AE, A squared E squared plus Y squared. Does anything cancel out? Please tell me something does. Did anything cancel? Oh, 2AE, 2A squared E squared. Yep, yep, yep. And then there should be a, this part's okay, EX squared, 2AEX. Does it look okay now? Okay, so then I'm going to group these together. I'm going to put the X squared E squared. Why am I missing an A squared? Little quick mistake. When I square both sides, because these are square roots, if we square both sides, this E becomes squared as well. And so I had forgotten that. Thanks for catching that. So it's E squared X squared minus 2AEX plus A squared. There we go. Now does something drop out? Because something should drop out. Yes, this one does. And then I'm going to put the X squared and the A squared together. I'm going to put the E squared X squared, and then I'm going to minus, right? Make sure I'm doing this the same as I did in my notes. X squared E squared minus a plus a squared is what they have. Yeah, plus a squared equals x squared plus a squared e squared plus y squared. Then, we're going to run out of time here. Then I'm going to swap these two because I want to make sure that we have a squareds together and x squareds together. Minus e squared x squared equals a squared minus a squared e squared. Now take out an x squared. You get 1 minus e squared. 1 minus e squared. Just a second. Divide by e squared, you get x squared plus y squared over 1 minus e squared equal to a squared. Okay. And divide by a squared, right? So you get x squared over a squared plus y squared, a squared, 1 minus e squared equals 1. And this is the equation of an ellipse where a is the major axis and b squared is equal to a squared times 1 minus e squared, which is going to be b is going to be the minor axis. But this is the equation for an ellipse.